So let's start with our first set of notes on triangle similarity, and we're going to draw from something we learned last semester. We studied congruent triangles where all three angles of one triangle were congruent to the three angles of the corresponding triangle. Likewise, the sides of one triangle were exactly the same size, therefore congruent to the sides of the other triangle when we have congruent triangles. But now when we just do similar triangles, there's still a relationship, but with similar, that's congruent, but with similar triangles, we'll put versus. Congruent triangles versus similar triangles, they will be dilations. Now, if they're the exact same, we call it a one-to-one relationship, which would be congruent triangles. But after that, we're either enlarging or reducing. So we open up the first part of the notes. A blank is a comparison of two quantities. That's a ratio. A ratio. The ratio of A to B can be expressed as A over B, where B is not 0. Okay, and this is why. I can't have A over 0, or that's an undefined term. Undefined number. Okay? We can name a ratio three different ways. We already discussed we can put the A over a B, just like you would see a fraction. That shows comparison. We can put A colon B, or we can write A with the word TO between the A and the B. They're all read the same. A to B, A to B, A to B. Okay, that's what a ratio is. A proportion uses two ratios on either side of an equal sign. It's an equation stating that two ratios are equal. To solve for an unknown inner proportion, all you have to do is cross multiply. That's what makes this unit so simple. So if I want to solve example 1, I think it's a little bit better if I use highlighters here. I'm going to do x plus 2 times x minus 2. And likewise, I'm going to do 12 times 5. Okay, the 12 times 5 is easy. It's 60. That's one side of my equal sign. And the other side, x plus 2 times x minus 2, you have two binomials, and when you have to multiply those, you take the first term of the first binomial, multiply it times both items in the other parenthesis. So that's going to give me x squared minus 2x. X times x is x squared. X times minus 2 is minus 2x. Then you take the second term times both items in the parenthesis. So that's going to give me plus 2x minus 4. And you should notice that the minus 2x and the plus 2x cancel out, and you now have 60 equals x squared minus 4. Add 4 to both sides to get rid of that, and you have 64 equals x squared. You don't want x squared, you want x. So the opposite of a square is a square root, and x equals 8. So you actually could say plus or minus 8, right? because negative 8 times negative 8 is a positive 64, and positive 8 times positive 8. So if you wanted to solve these additional problems here to decide, are these ratios actually proportional, 6 times 14 would have to equal 8 times 9. Well, 8 times 9 is 72, and 6 times 14 is 84. So that is not proportional. I'm putting that line through that to say no, not a proportion. Let's try 80 times 36 and 120 times 24, and we will get 2,880 does equal 2,880. Therefore, yes, it is a proportion. So now let's look at similar triangles. You first have to determine if they are. They gave us these two, and the way to check it is always think, this is silly, but French fries. Each of these triangles, since they're scalene, has a small, a medium, and a large side. So here's probably actually my medium, here's my large, here's my medium, here's my large. Okay? So in order to determine if they really are similar, all their ratios for the similar sides would have to be at the same ratio. So that means my small side's 4.5 compared to 9 has to be at the same ratio as 6.6 is to 13.2 as 8 is to 16. Well, 4.5 doubled is 9. 8 doubled is 16, and 6.6 doubled is 13.2. So this is, they all reduce to 1/2. Those are similar triangles. We'll learn in a couple days that side similarity will always exist. So what is always the same in two similar triangles? Well, you can see we have a 56-degree angle here and a 56-degree angle here, a 34 here, a 34 here, and a 90 in each. So the angles always have to be the exact same size. What's happening is your triangle with the angles can be like this, and as it expands, the angles don't change, but the side lengths do. So what's different? The side lengths. How are they different? So in this one, triangle KHS is 1/2 the size of triangle WIN. Could I have said it in reverse? Could I have said triangle WIN is twice as big as triangle KHS? Sure. It doesn't matter which way I go when I'm making a statement, because both of those are true. So this is a, since we started on top and came down, a 1:2 ratio. So congruency statements. If we're going to compare the angles, we're going to say angle K corresponds to angle W, they're congruent, Angle H is congruent to angle I, and angle S is congruent to angle N. And for the corresponding sides, why don't we just use our colon to show KH corresponds to WI, and HS corresponds to IN, and KS corresponds to WN. I could have said SK to NW, still be correct. So the last little piece they want us to try here is to actually look at a triangle. It says, given two similar triangles, write and solve proportions to determine missing values for RGT. That is the big triangle. Let me put that in pink. RGT. And IGH, which is the little one, at the top. They want to know if those are similar and how to solve. For some people, it's going to be easier to redraw both triangles to really clearly see that the sides of the large one, 8 plus 4 is 12, 10 plus y is that side. This is 15. And up here we have an 8, a 10, and an x. Since we're trying to solve for x, the missing side, and it corresponds to 15, we definitely want to say x from the small triangle compared to 15 on the large one would have to equal, why don't we say the 8 to the 12? 8 to 12. When you cross multiply, you'll have 12x equals 120. Divide both sides by 12. X equals 10. See if there's anything else. And then they have a y here. So we'll do a different setup for y. We could still use, let's see, here's our large side here to 10. So we're going to do our 10 from our small triangle to our 10 plus y for the long edge of the pink. And why don't we still use our 8 and our 12? So that means we're going to cross multiply. I'll move my work up here. We'll say 120, which is 10 times 12. And then we have to do 8 times 10 plus y. So your 120 equals 80, which is 8 times 10, plus 8y. That's at 0. Minus 80 on both sides. 40 equals 8y. Divide both sides by 8. And y equals 5. We've now solved for both unknowns, and those are some examples you can use as you go on to practice problems today.